Hello everyone, I am Khadiravana, a 4th year undergrad at IIIT Hyderabad. We are here to present to you the paper DocVisor, which is a multi-purpose web-based interactive visualizer for document image analytics. The authors of the paper are me, Pranav, who is also a 4th year undergrad at IIIT Hyderabad, and my advisor Dr. Ravi Kiran. There are various document analysis tasks, the most common being optical character recognition task, commonly referred to as the OCR task, which involves recognition of text from images, instance segmentation task, which involves extracting semantic regions of interest from document images, and table segmentation task, which involves detecting and extracting various regions from table image data. For most tasks, we summarize the performance of the model used using a metric. For example, for the OCR task, we have metrics such as CER, the character error rate, and WER, the word error rate, which effectively summarizes the performance of an OCR model. The lower the CER and the WER, the better the model. Here is an example of a comparison of the error rates of various baseline OCR models for typed Sanskrit line images. In the case of instance segmentation, we look at measures such as intersection over union and Hausdorff distance to evaluate the accuracy of boundaries obtained with respect to the ground truth annotations. Higher IOU and lower HT values correspond to better model performance. The table shown here is an example of a comparison of values obtained for different metrics for various baseline models along with the parameter model. Most times, these performance measures are summarized using a single aggregate number. While effective, these single valued metrics fail to capture the inner details of the actual performance or failure of a model. A good example of that would be the IOU metric used in the instance segmentation task. An IOU of 0 would generally mean that there is no intersection of the ground truth annotation with the predicted polygon. However, in instance segmentation problems, this could correspond to a false negative in cases where there is no corresponding model prediction, that is, the model has not recognized the region. Similarly, in the case of the OCR task, CER and WER are good measures but will not be able to capture inner patterns such as response of the model to a particular font or repeated misprediction of a particular character. As researchers, these inner details can help us improve our model by diagnosing the problem, be it as simple as an overfitting issue or as serious as an architectural flaw with the existing model. So what we need is a tool that has the ability to navigate through the data such as ground truth, predictions, and possible intermediate model outputs at instance level. We also need to be able to reorder the data by sorting it using metrics of our interest. We also want to be able to compare multiple model outputs wherever possible. We would also like to visualize intermediate outputs of the model, if any, such as the attention matrix of Sanskrit OCR, which uses the attention mechanism, or the Gaussian outputs of boundary net. These are the features that would help any researcher working on these tasks. DocVisor is a tool that meets all of these features, thus enabling more effective analysis of models. It is an open source, web-based, multi-user tool. It is built using Streamlit and React. The tool is well documented for the use of the community. The links to the source code and the documentation are mentioned. DocVisor supports the visualization of three main document analysis tasks, namely OCR, fully automatic instance segmentation, and weakly supervised instance segmentation. We shall now look at the various features of DocVisor's layouts and how they will be useful to the document analysis community. We will begin by looking at DocVisor's OCR layout. For the purpose of this presentation, we will be using the data used to train the Sanskrit OCR model and the corresponding model outputs. An OCR task generally consists of the following basic data: the image, the ground truth text, the predicted text, and the corresponding metrics. The image shown is the basic layout of the DocVisor's OCR page. The layout displays an image along with the corresponding ground truth, model predictions, and the corresponding metrics. We shall now look at multiple salient features of the DocVisor's OCR layout. Many times, while performing experiments, we train our models with different settings. Sometimes we would like to compare the results across all models at our disposal. The OCR layout of the DocVisor tool has the provision to do so. Here is an example of an image, its corresponding ground truth, and multiple model predictions. Models could have attention as a part of their architecture, or they could be non-attention models. The attention models are distinguished by the star character appended towards the end of the user-defined model's name. In this example, the Indic OCR V2C3 and the Indic OCR V2C1 models are the attention models, and the remaining are non-attention models. Along with the predicted output for each model, we are also displaying the corresponding instance error rates for numerical analysis as well. Text to image is an OCR layout feature for models that contain the attention mechanism. This feature allows the user to select a substring of the predicted text and get the corresponding portion in the image highlighted. This GIF represents the text to image feature of the OCR layout. Similarly, we have the image to text feature. This feature allows the user to select a subportion of the image and visualize the corresponding model's predicted substring. This GIF represents the image to text feature. Notice that on selection of a particular subportion of the image, the OCR layout visualizes the corresponding substring across all the predicted model outputs having the attention mechanism as the part of the model architecture. In order to use the text selection and image selection of the DocVisor's OCR layout, the model used will have to have the attention mechanism as a part of their architecture. For focused analysis, the tool provides the ability to sort the data using any metric of interest. This picture depicts the option provided to the user to select the model on which basis the data points need to be sorted. A task can have multiple user-defined metrics for summarizing the performance of the model. The picture depicts the option provided to the user to select a particular metric to sort his or her data. Finally, the user can choose to either sort the data using a particular metric in either ascending or descending order. This is depicted in this figure. The OCR layout also provides the user the ability to view the difference between ground truth string and the predicted string using the diff visualizer component of the layout. The picture here depicts an example of the diff visualizer. The main aim of the diff visualizer is to visualize how close the target string is to the reference string. We visualize this by finding out the minimum edit operations required to convert the target string to the reference string. By edit operations, I mean operations such as insert, delete, and replace. Each of these operations are color coded. The documentation required to understand the color coding is provided right below the diff visualizer component in a table as shown in the figure. Apart from all these features that the layout has, it is also provided with configurable user settings. This picture depicts the various settings that the OCR layout provides the user to configure according to his needs. The configurable settings include, but are not limited to, the font size of the predicted text, the color to highlight the image while using the text selection feature, etc.
The next layout we'll look at is the fully automatic instance segmentation layout. The key feature of this layout is the simultaneous visualization of model outputs on a per instance as well as on a full document basis. This allows the user to understand the model output with depth for a single instance as well as to understand how the model performs for the document it belongs to as a whole. The GIF shown in the following slides demonstrates the visualization process for popular document segmentation tasks. The user can visualize polygons, points, and mass of the given model prediction depending on which is better suited for the task at hand. The user can also select the region class which they want to visualize, and DocVisor will only serve data corresponding to those region classes. Additionally, the user can select to visualize full documents only without instance level outputs. Similar to the OCR layout, the fully automatic segmentation layout supports sorting and navigating through the data by a given metric. The last layout in DocVisor is the weakly supervised instance segmentation layout. The user can visualize various intermediate model outputs along with the ground truth annotations on a per instance level. Similar to the previous two layouts, the weakly supervised instance segmentation layout also allows the user to sort the data by a metric. There are also some user-friendly features that enable the user to have a better navigation experience. Users can select those outputs they wish to fix without having to select those outputs each time. Users can bookmark those instances they wish to navigate through separately, and so by clicking the bookmark button, a separate bookmark section is added for navigation. Additionally, the user can save the instance data for offline analysis. This image represents the DocVisor architecture. Model outputs are obtained and stored in JSON files, which behave as a database. DocVisor then parses these files and serves the visualized data to the user for that particular layout instance. Multiple users can utilize the same DocVisor instance concurrently. We will now look at the installation and setup procedure for DocVisor. The DocVisor GitHub repository can be cloned by running the following command on the terminal. Alternatively, users who do not have Git installed on their desktop can download the source code as a zip file from the following link. Once the code has been set up on your system, change your current directory to the clone DocVisor directory via the terminal. Then create a conda environment using the command shown. Activate the conda environment. You can ensure that the conda environment has pip installed by running the command which pip. If the pip executable is not inside your environment, install it by running conda install pip. Now install the required Python libraries from the requirements.txt file provided in the code by running the following command. To run DocVisor on custom data, one needs to prepare metadata files for each layout that DocVisor will contain. An example metadata file is shown in the current slide. The user also needs to create JSON data files corresponding to the data which they wish to visualize. There is a detailed documentation present which explains the setup procedure thoroughly with example files. The DocVisor codebase comes with ready-made data files which the user can run and get hands-on experience on how the front end works. If you have not made changes to the code, the DocVisor example setup can be launched using the command /run.sh. Ensure that you are in the DocVisor repository for the script to work. This should launch the tool on your local host on the port 8501.
Let's look at DocVisor's interface. The sidebar on the left allows the user to change settings related to the app. The first dropdown allows the user to select the layout they wish to visualize, and the second one allows them to select the instance of the layout. They can visualize the split which they desire, so train, test, and validation data. And they can also sort the data by a specified metric, in this case the intersection over union and Hausdorff distance. They can also select the order in which to sort the data, so an ascending or descending order. In the main page, the user can select the region class they wish to visualize by the drop-down at the top. A slider, along with previous and next buttons, allow the user to navigate between the data. If specified, the collection information is also shown for the data. The main feature of the layout are the visualization plots. Here, the user can select outputs to overlay over the corresponding region image. By default, for the fully automatic layout, the mass are visualized for the ground truth and model predictions. The user can also visualize the polygon and points for the data. The display options menu on the left allows the user to fix those outputs which they wish to. Below this, the metrics are shown for the current region, so in this case the IOU and HD. Finally, the entire document is visualized along with region outputs. The current region being visualized is shown in red in the full document. In addition to browsing data in a region-wise manner, users can also choose to browse through the full documents alone in the drop-down menu. Here, the metric values shown are averaged over all regions of the document. Now let's look at the box supervised region parsing layout. This layout is identical to the fully automatic layout, except that the data is visualized on a per region basis only. Additionally, the users can visualize any intermediate outputs they wish to visualize. Coming back to the point about IOU equal to 0 for some instances, we will see how DocVisor allows the user to qualitatively assess possible model shortcomings. If we sort the regions by IOU in the ascending order, we can see a case of a false negative. The model has no prediction for the corresponding ground truth. As we move the slider to the right, the predictions get more accurate. Hence, we have a far more logical navigation process as compared to navigation without sorting.
Let us see a similar example for the DocVisor's OCR layout. Remember that for the OCR task, lower CER and lower WR are desirable. Now we have a set of data points in this particular demo. Let us navigate through the data points using the sorting feature and see how the navigation provided by the DocVisor's layout is useful for better analysis. Let us now sort our data points using the model performance of the Indigo OCR V2C3 model. Let us use the CER metric and let us navigate to the data points which have from higher CER values to lower CER values, that is in the descending order. This would mean that as we navigate through this navigation slider bar, we will be seeing the worst CER in the beginning, and as we navigate, we will be getting better and better CER values. One can see in this example that the prediction for this particular image by the Indigo OCR V2C3 model is not that good, and hence the higher CER and WR values. As we navigate using the slider, the predictions get better and better. This sort of focused navigation will help the researchers analyze their model predictions in a much better way.
In comparison with other document analysis tools, DocVisor stands out in that it fulfills various requirements which are extremely useful in the analysis of document-related tasks. We are currently working on some improvements and features to add to DocVisor. The key updates include out-of-the-box support for various popular OCR and segmentation data formats such as HOCR, LaTeX Math, Page XML, and MS COCO. The new version will also have a much more flexible input-output mechanism in the backend, which would enable the user to customize the tool however they see fit. Thank you.